Hi. Okay, what I'm going to do here is show how to program the MGP panel decoders. In this case, this board has, I guess it's 21 LEDs are controlled by one decoder. So I needed 60, yeah, 63 LEDs. 63 RGB LEDs, so times 3. And so that means I needed 3 boards. So if I flip this around, you'll see that see there's right now I have 2 boards installed. So one board here, you can see here it's not using the input switches, because I only need about 31, yeah, 31 switches. So each board gives 16. So this board will give 16 switches. This board will give 16 switches. So that makes 32. And so I don't need this one, but I need this one for the lights, for the string of lights, because each board does 21 RGB LEDs or 64 LEDs, independent LEDs. Here I'm just giving it power 5 volt, which would power the whole board, and also this board, that board, and then this is the local net connection. It would go from one to the other. So right now I'm programming this board here. So the way I identified is in 3 sections: 101, 201, and 301. And the way the LEDs work is that it's like a string of Christmas lights. It's one after the other. So like, let's say this light, the way it's wired up is the output. There's a plus and minus from this board. Yeah, you see the way it is it has a connection over here, right up here. Each board has a connection there, and there's a ground, 5 volts, and a signal. So in this case, this board 301, the signal, there's a wire on the PC board that comes directly to the first light, which is, I think it's this one here. This would be like 301, and then this one over here, I think it starts. This is 201. So 201 series kind of goes around, wraps around here. So like one light is connected to the next, to the next, to the next. So however you design it, you have to know in what order the lights are going through in sequence. So since there's power connected here, I can run a test that will show me the lights as they go through. So right now I have 2 boards. So the section 201 is running and the section 101 is running. 201 and 301. So now I'll go to the tablet here and see, I'll call it up. So 301. So it's loading the board through the Bluetooth interface to the tablet. Okay, then up here, I'm going to select General. And there's some information down here. Yeah, see right down here, it's written a test sequence. LED, so I say edit. Change that to 64. You can see it there, and then I say write. Now it writes it to the board. Now if I go back to the board, you should see them sequencing. So the way these lights, these RGB LED, they are red, green, blue. So you'll see the lights go on. See, it's going through the ones that are already on, and then I'll cycle again. See, let me see. And the first LED will stay red a little bit longer than the rest. It might be hard to see them, but let's see if we can catch them. See, so you can see how it's stringing along. So I think this one here is the first LED. We'll see when it gets there. And I'll count the 3 colors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 35, 36, 37, 38, 39, 41, 42, 43, 44, 46, 47, 48, 49, 50, 51, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63. And then see, now it goes back to 1, 2, 3. See, so that's how that's, hopefully you're able to see how that, those colors arrange. It might be a little bit difficult to see with the glare, but that's how that works. So once I figure out how they are here, then I have all the, I know what tracks they are. They're identified, and on JMRI I have the information. So what I'm gonna do is, the way I do it is that the red light will be for block occupancy. The green light will be for when I select a route. So that'll be a turnout selection. And then the blue, if it's like on the lower level, I have like a up line and the lower level. So the up line will, the light will be blue when occupied and not green, blue when selected and not green when selected. The lower line is green is selected and not blue. So I have to decide, is this where the light is coming on, is that on the up or on the down? Okay, and then like I said, the red will be for block occupancy. Okay, so the next step in wiring up these or programming these panel decoders is figuring out how the lights work, the LEDs. So in this case, these boards, they operate 21 RGB LEDs. These are RGB LEDs, which could be red, green, or blue. Or you can have 64 independent LEDs. What I mean by that is, like you see on this board here, the way I did it is I separated the each one, they're green LEDs. They only, they have 2 leads, a positive, and then the other one is a ground, and it goes to it'll end up going to this board. What happens is, again, they're single, so this would be LED 1, LED 2, 3, 4, 5, and then you do 64 LEDs. But every time you trigger an LED, it'll always be green. In this case, if you use this board, these LEDs are RGB LEDs. They have the 3 colors, just like these LEDs over here. These are RGB LEDs. Each one will do the 3 colors. It could actually do more than 3 colors, but the way, for this purpose, it's set up as 3 colors: the red, the green, or the blue. So in this case, the first LED, if you wired it up, you brought your power, ground, and signal here, this would be LED 1 would be red, green, blue, which they give it in this list here. The way they set it up is they set it up LED 1 at the top. See, they have 64 LEDs. See, so they have LED 1 all the way down to 64. So in reality, it's it's 21 LEDs, as I said. 21 times 3 is 63, and then you just have one extra LED. So 21 groups of 3. Okay, so in this case, LED, according to that list over here, this would be LED 1, 2, and 3, and then this would be 4, 5, 6, 7, 8, 9, 10, 11, 12. So for instance, if you wanted LED, or if you wanted the third LED, the third RGB LED to go red, you would have to count 1, 2, 3, 4, 5, 6. That would be 7, because it would be red, green, blue, red, green, blue, red, green, blue. See, so I even drew a list over here, down here. See the way I set it up over here. See, LED 1 is red, green, blue, red, green, blue, red, green, blue, so forth, so forth. So if I wanted, for instance, the RGB LED number 12. So if there was a, let's say, in this case, 1, 2, 3, 4, 5, 6. If I wanted that sixth LED to be blue, I would look at my chart, I would say 6, then RGB, blue. Okay, so that means address, I would have to give, according to that list here, I would have to set LED 18 to trigger on and off. And when I turn it on, it would it would show the color blue. If I wanted that same LED to show the color green, I would have to say trigger 17 to trigger the green. And if I wanted red, it would be 16 would trigger. So that's how that sequencing works. Now the thing is, the RGB LEDs, they start off like this on the strip, so they're physically connected one after each other in order. But then when you put them on the board like this, well, you gotta, figure out a pattern. So now the thing is which is LED 1 or RGB LED 1, which is RGB LED 2, and then all the way up to RGB LED 21. So in this case, the way that board is set up is I have 3 sets. Well, this one is, it's not, you don't have the boards in the back, but basically you can see here the outline is like 3 boards would go here. So this would be one group of 21 LEDs, RGB LEDs, a second group of 21 RGB, and the third one. Now the thing is, the way to understand them, to know which lights I'm triggering, because I could be turning on the first board, let's say RGB LED 1, how do I differentiate that one between the first RGB LED on board number 2 or the first RGB LED on board number 3? So basically I'll number these 101 to 164. This one will be 201 to 264, and then 301 to 364. So that's what I'm doing. So I would do that. And then the thing is, you can run the test sequence, which is here on the top. Test sequence, let me see. Focus here. Yeah, LED test sequence. Whoops. LED test sequence. Tap that, then I could tell it, okay, I wanted to do the 64 LEDs. 64. And then I tell it to write. So it changes from red to white. And now this board, which is the one I'm actually talking to, see the 64 LEDs are going in sequence. So now I would have to identify, okay, which one on these, what is the position on this board. See, it'll go cycle through, and then it'll go back to the first LED, which was this one down here. See? Comes on a little longer, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it'll cycle through all the way to 64. So this is how I can count or where they are. So what I can do is take a piece of paper, draw this map, which I'll show you in a minute, and then identify where these LEDs are. Okay, so what I'm doing here is I want to trigger those LEDs. So what I'm doing is, since it's board 2, I'm going to give it a starting address of 200. So it'll be 201 to 264. Okay, so the first LED, if I give it a switch closed to address 201, which is the first LED, it'll go, oh, where's the up here? Yeah, red. It'll go red. And then the second LED will be green, and the third LED will be blue. So 201 is going to be the first LED 1. 202 will be again the first LED green, and 203 will be the first LED blue. Then 4 will be the second LED red. 205 the second LED green, and 206 will be the second LED blue. So then you can continue that all the way to 64. So red, green, blue, all the way. 21 LEDs, 63 positions, 64th one is extra. So now what happens is if I go to the panel here, let's see here, and now I'm going to trigger. In my case, I'm using this this device here, focus, and I'm going to say address 2. See, it's starting at 201. So I'll toggle. So now what you're going to see here going on is see that red. So 201 is getting him on the throttle close position. 201 is turning the red on and off. So this is close, throw. And then 202 is the same LED, green, on, off. And then 203, the same LED, blue, on, off. And then 204 is the second LED, red, green, blue. So if I wanted the first one to be green and the second one to be blue, I would say 202. And then the next one would be, if I wanted it to be blue, 206. Okay, you see how that works? Okay, so as I mentioned earlier, what I do is I can, let's say, print a paper of the layout, and then set the test sequence for the LEDs to go, keep going in a pattern as you see here, right? And then when it'll restart, and this will be, I know that this is a 201, that's LED 1, LED 2, LED 3, LED 4, and so forth. So then as they go along, I write it down on this paper. So I know LED 1, 2, 3, 4, 9, 10, 11, 12, there's 13, 14, 15, 16, 17, 18, 19, 20, and 21. So what I could do is, let's say now, so that's one way of getting it, is by setting the test sequence to go, or since I programmed the turnouts, 301, or in this case 201, 202, 203, 204. So let's say if I wanted LED 15, 15's over there. So I look over here and I see 15 is 43, 44, and 45. So I know that if I triggered 243, on the panel would go red. If I triggered 244, it would go green, and 245 it would show blue. So either triggering here, because as I said before, I had set the triggers for the closed turnout triggers for LEDs. I could see what they're doing there. So that's how I can identify the which LED is doing what. So in this case, I say, okay, I know. Let's say we'll pick this one here, number 19. So I know that 19 is what I call Mullins 1. So I'll look up here on my board. Move some of this stuff away. Here's the turnout. Yeah. So Mullins, let me see if it's focused. Mullins 1. Let me see. Mullins 1. Where's Mullins 1? See, Mullins 1 here is 34. 34. So I could trigger. See, when I go red here, I can trigger it. There you could see up there, see it's turned red. So now I know that that's the right spot. So that's LED 19. So red for RGB LED 19. If I look on this list, it's 50. It's LED 55. See, so I want it red. So now I gotta change. And again, LED 55 on the decoder is in the 200. It's a 200 board that I'm setting. So if I go to LED 255, or in this case, since I'm already on the 200 series, so I go to LED 55. And yeah, see, I have to change it, and I already did. I set it status occupied to 34. So now I know that it's gonna go red, that LED. And then yeah, 19. If I wanted to go green, I know it's, again, the other thing is I know that it's on the up line, so I'm not going to use a green LED to trigger the root. I'm going to use a blue LED. So if I go back, LED 19, see 56, so it's LED 56, which is the next one, 56. See, I'm setting it to none because I'm not using the green. But the blue LED, 63. See, 63. I know it's 63 because if I go here to my turnout list, 63, 63. See, Mullins 1. See, close, throw. And then 64. See, Mullins 2 is 64. You see, so this is how I figure out which LEDs have to be, what's going to trigger them. Because again, on this list, I know what all my turnouts are, the roots, because I'm setting the roots on the panel. So this is my my turnout table, and this for the roots. This is the sensor table to tell me which ones. So, like I said, I double check. Mullins 2, I know here. Let me see, Mullins 1, and then Mullins 2 is 30. Is a sensor 30. See, if I turn 31 off, I put 32 on. If you look over here, see, that's bottom track, that's Mullins 2. I know that. See, I've triggered it here. It went right over there. So now how do I do it here? Which is the LED? Actually, the LED is on the other board. It's not one of these LEDs. So I would have to load in the other panel, the 301 panel, or either the 301 panel or the 101 panel, because again, this is broken up into 3 sections. So hopefully that makes sense about how to set the LEDs. It's a lot of things you have to figure out. You have to figure out the RGB LED, which one they are on the table. You have to figure out what individual LED they address. I don't know if I should use the word address, but yeah, address. And then to trigger, and then with that you just go through your whole list, and then you have to start changing all the what triggers the roots, what triggers the block occupancy, and that's it for now. Thank you. The other thing I wanted to point out with these panel decoders and signal decoders is that the logic is built into the boards. You program the boards with, let's say, the roots, and it's stored in there. So what happens is in GMRI, you don't have to do it in GMRI. GMRI doesn't have to be running. I have it because I want to have this chart. I want to be able to see it on the monitor. I want to be able to see what I've programmed as the steps, the sensors, and then the turnouts, and then I guess also the roster. But again, the smarts is not done here for the roots. The roots, let me see. I'll turn if this tablet is working. So I'll turn off the LEDs. Let me see. Input. Yeah, see here, there's a setting here for roots. So what you would do is, let me focus. So you would say start a starting address. Okay, in this case, let me see. I'll go to one that is already exists. Let me see. I think I put it in here under this group. So it's reading the detector that's on the layout decoder. So I'll go to roots. See, my first address here is, so I'm starting at route 41, which matches also here. See, this guy's starting at, the roots start at 41. See, 1 to 40 are turnouts, individual turnouts, and then 41 and down are roots, so which is a group of turnouts. So here I say, yeah, turnout. So the first address will be 41. So root. So 1 will be 41, 2 will be 42, and so forth. So in this case, I say, you see it. Let me see. Is it focus? Yeah. It says used for switched roots. So you can change these. That's what's nice about these boards. You can have them set a lot of different. Used for switch roots. Not used for switch roots, used for occupancy roots, used for switch feedback grouping. So there's a lot of choices. So in my case, I'm using it for roots. So here I would say, okay, the switch address, switch. So for the first root, root 41, 15 has to be closed, 16 throw, 12 closed, 14 thrown, 71 closed. And so that's what that. So 41, when I do 41 close, it'll flip those turnouts. So and now, if all those turnouts are flipped in the correct position, well then when the root button, the green LED will come on. If the roots are not, so if this is not true, one of these turnouts is flipped in another direction, that light will the green light will turn off. So, and then see root number 2, see again, see 15 closed, 12 thrown, 2 throw, 14. I think I have, let me see, 6 positions. If you need more than 6 positions, then like what I'm doing here is I actually need more than 6. So I'm setting up turnouts, which are like, we'll call them virtual turnouts. They're extension of turnouts. So it's like a continuation. So I would say, let's say, in this case, 72. So I'm saying, okay, go to the root 72, and root 72 has, let's say, another up to 6 turnouts. Or, root 71 or whatever. So it's a continuation, an extension of if you need more than 6. So that's how that all works. So what's neat about, again, with the green light, is what I was saying earlier is when you select a route here, it flips all the turnouts. Oh yeah, I'll have to flip it. Okay, I'll take flip 2. So 42. So it's if all the turnouts are flipped, that light will go green. Now I go to the next one and I say, okay, flip these turnouts for route 43. Now all the routes are flipped, and it's checking the feedback. This is what's important. It's checking to see, did all those turnouts flip in the right direction? Yes, they did. So now it's saying route 43 is true. So now it's green. But because some of the turnouts from route 42 are used in route 43, then they're switched to a different position. Now route 42 is no longer true, because some of them are, like I said, in a different position. So because they're in a different position, it's no longer true, the light goes out. So this is what's important. This is how you kind of share, in this case, I'll press this guy, that route will come on. Again, these lights are not programmed yet, so you don't see it there, but you'll see it here on this panel. You see? If I press this guy, this route will go out. Let me see if I could focus. Yeah, this one goes out, this one goes out, this one goes on. Because the turnout here is no longer true going there, and this one is no longer true going there. So it goes out and it comes here. Just like up here, I could select this route. Those LEDs come on. All those turnouts, it's checked. It doesn't just come on green. It checks to see, is that route true? Yes, that route is true, because all the turnouts gave a feedback to say, yes, we're in the right position. Light turns green. Next one, it's all those turnouts flipped. Yes, okay, I'll turn green. The first one, it's no longer true. Some of them were flipped to go to the other route. Okay, I gotta turn the green LED off. So that's how that all works. Okay, and here is the design for another panel, which is this one here. So it's a different. This one uses only 2 MGP panel boards instead of 3, because I'm doubling up LEDs or tripling up LEDs. So you'll see this is well, let's watch them go along. You'll see where they double up. You see, we'll go through here. These are all singles. Here, this one will double up, I know. See, double, that's a single, that's a single. This one has actually 4 LEDs, this one has 2, this one has 3, this one has single, 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 single. See, so that's LED 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. See, so that's my 21 RGB LEDs. And they, as you know, they go red, green, blue. Or sorry, in this particular case, this board, the LEDs are set up as green, red, blue. See, so it's something you have to pay attention to. The other board is RGB, this is GRB. So that's the one panel, and then now I'll trigger the second panel. Okay, so for the second panel, I have to load it up. So here we go. Second panel is this one, 1002. Read in the panel, all the data. Then I go to general. Then I go here, test sequence, and change it to 64, which I did. So now that I change it to 64, and then you do a write, and you come over here, and you'll see it scrolls through. So let me see. I think this is the first LED. As I said, the first LED stays on a little longer. There you go. Green, red, blue. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And then it starts over again, you see? So by watching it here, the sequencing, and I'm able to copy it to this list. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 2 12s, there's 1 13. 114, there's 4 of the 15, 16. So now that I know what they are, then I'll have to go over here and then say, okay, what's you know, if I'm gonna say, oh, LED, let me see, LED 20 is this one here, LED 20. So what's the address for LED 20? I check here. LED 20 is address 58, 59, and 60. Excuse me, but you have to recall that on the other panel decoder board, they're RGB. This one is GRB. So I have to think, okay, the red will be the 59. So green, red, blue. So green will be the first one will be green. So it means that the LED 58, what's going to trigger the root, and then 59 is what will trigger the block occupancy, and 60 is also the root. Again, is it up line or a lower line? In that case, it's a lower line, so that means the 58 has to be set to 0, and 60 has to be set to close. And it's since it's I know, again, Mullins 1. I know Mullins 1 according to my list. You know, what is Mullins 1? Let me see. Yeah, I was saying here, let's say LED 20. Let me go to LED 20. See, 42 is occupied for red. Oh, 58. What am I doing? What am I doing? It's 58. 58 is the blue. Am I reading the right panel? Yes. Yeah. 20 is 58, 59, 60. 58, 59, 60. Wait a minute. Let's see what's going on. So it's 58, 59, 60. But the way it looks like here, 58, it's almost telling you, I'm almost getting the impression that this blue, oh no, green, yeah, green, red, blue. So yeah, green, okay, we're good. Yeah, I'm a little confused, sorry. So I'm not using the green because it's on the up line. Then it's red. So what is red? 25 will trigger block occupancy. So status occupied. So if Mullins 1, LED 25 occupied. So if Mullins 1 is occupied, that LED will go occupied. And then I want the blue. So what route is that? That's closed. It's trigger 62. So that is route 62. Because if I go to my table on JMRI, 62 is Mullins 1. Yeah, okay. And then, so you just have to put them all in, and then you're good to go. That's it. Bye-bye. Okay, so the other thing I wanted to point out is the yellow light, the yellow LED. Because remember I was telling you red, green, and blue, but there's also, the system is making a yellow, and I think there's also a purple. I'll show you an example. For instance, this route here, route C, which is 43, it's green. See, I select green. If I select the other route, that route goes green. That route goes green. That's because the route is selected and it's unoccupied. In this case, I see here that there's a red light. That's red. Hopefully the camera picks it up properly. That LED is red because that block is occupied. But if I choose to, let's say now I want to remove that locomotive or that train from that block, if I select that block, it goes yellow. The reason it's yellow is because it's both red occupied and it's green selected. So red LED is on and the green LED is on, so it's showing a yellow LED. Hopefully the camera is picking it up properly. And that's on the lower line. The mountain line, these are the mountain lines. So you could see this route is selected, it's blue. So it means it's selected and unoccupied. The track up here, it's occupied, so it's red. Now if I go and I select, well, I'm going to take that locomotive out of there. So I'll select that track. The blue goes out because that route is no longer true. And this route up here, it might be tough to see that, but that's a purple color because it's both blue because the route is selected, and it's also red because it's occupied. So red and blue gives you this sort of purplish color. So this is what's important to see, how there's extra lights to show you, or extra colors to show you different things. See, this blue, this guy is blue, and now if I actually put a locomotive in there, it'll turn from blue to the purplish color like that one. And see these tracks here, this is green. If I occupy that, it's going to go both green and red, so these tracks will turn yellow. Okay, thank you. And the other thing I wanted to show you, as far as the sensors, you see that sensor list. And if I go block A, if I make it occupied, that guy goes red, and here that track goes red. But then also this track, see, A goes red. And the other thing is, on the layout down here, I actually have LEDs here, see, in the track. So track A, red. Here, this is a route that the train's going to take. So there's a LED green at this end and green at that end. There's a locomotive sitting, so that guy is red. that guy is red. If you look back at this panel, this guy is red. So because it's LocalNet, all the panels are talking to each other. So whatever changes I make here will show there, and vice versa. If I move this locomotive, let's say to track, this would be, or let's say 42. See, that guy goes red. This one, that's center 2, so that's center 2 for track, center 2 for track 2 or 42, because it's triggered with addresses, as I was saying before, 41 to 49, and then there's, see, I even have some switches here. See, 50, 51 is these two tracks here. 52 is this track that's here. See, if I select it, the light will go green there. This light will go green here. You might not see it, but on the JMRI, the turnout, you see it's going to that track, 52. And let me see here, and then here, even if you look here, 52, see it's set to close. And then here is the LocalNet answer, what's happening output on LocalNet. So I could see up here, you see it says requesting switch 42, route L, Daint Yard, closed. And then, and route 52, it, let me see, just click. See, route 52L, where did I see it? Yeah, see it's flipping turnout 16 to closed, and let me see, yeah, 16, 71. See, so it's giving me a breakdown of which turnouts it's flipping as it goes. So that's what's nice about the using these decoders and LocalNet. So I could say that it's not occupied, and I can go track 2, be up there. You see that one's occupied. Let me see, track C, 1, 2, C. So there you can see here, it's the third track, C is there, occupied. If I go to this panel, A, B, C, see, occupied. This guy, occupied. That panel will be occupied. And even the LEDs on the track will be occupied. Even physically, it's not occupied because there's no locomotive. You see here, this is track 3. It's saying occupied because I force it to be occupied. So that's how that all works. So again, LocalNet and updating, and the smarts are in the decoder. That's the way it goes.